Good day everyone, we are the Group 5 from Bsce 2M. We are going to show our final performance innovative test in CE 324, numerical solutions to CE problems by solving systems of linear equations. Before we start, let me introduce myself. I am John Engelbert Macasa, with Miss Shikaina Bigafria, Rosemary Kaubanan, Kendra Galiniero, May Pipito, Rafael Mendoza, Jubert Supilanas, and Jamaica Vale.
Let's learn first the objective of this performance task. First is to formulate the model equation derived from this equation or problem stated. 2 is to simplify the equation and solve for what is asked in the problem with the use of numerical solutions. And here's the situation. After the thorough investigations conducted by the geotechnical engineer, it was found that the site soil does not meet the requirements for a regular pad foundation. The civil structural engineer decided to design a rock pile foundation which was limited to 5.52 m³ of concrete when poured monolithic. The civil engineer came up with a foundation with 4 sets, 9 in depth of cylindrical in situ pile, design and dimensions related to the diameter x of each pile. Compute the diameter x of each in situ pile.
As you can see in figure 1, it's the mock-up design of rock pile foundation, and we can see that it has 4 sets of piles. And here in figure 2, we can see the orthographic drawing with dimensions that is relative to x. Looking at the top view, we see a truncated square pyramid that have base side A equal to 3x each side, and for the base side B is equal to 1.5x. For the front and side view is the same. We have dimensions of the x for the diameter of a cylinder, a 1.25x for the height of truncated square pyramid, and x for the height of the cuboid. Lastly is for the embedment type view, we have the height of a cylinder which is equal to 9 meters.
Computation. To solve the problem, we will follow this step. Step 1. Formulate a model equation. To formulate the model equation, we will use the figure 2. As we see from the figure discussed by Rafael, we have a cylinder, cuboid, and a truncated square pyramid. From this, we will use the equation total volume equals the sum of individual volumes and let everything in terms of x. So for a cylinder, formula for volume is V equals pi r squared times height. To let that in x, we have volume equals to pi x over 2 squared times 9 times 4 since we have 4 cylinder. So volume equals to 4 times pi times x over 2 squared times 9. For cuboid, we have volume equals to length times speed times height. We get volume is equals to 3x times 3x times 3. For truncated square pyramid, we have 1/3 times a squared plus ab plus b squared times height. So we have volume is equals to 1/3 times 3x squared plus 1.5x squared plus 3x times 1.5x times 1.25x. And simplifying the equation, we get volume of cylinder is equals to 9 pi x squared. Volume of cuboid is equals to 9x cubed. And the volume of trapezoid is equals to 6.5625 x cubed. Now we can have a model equation that is equals to the total volume which is given in the situation. That is equals to 5.52. And the sum of individual volume, we get 5.52 is equals to 9 pi x squared plus 9x cubed plus 6.5625 x cubed. Transposing 5.52 to the other side and simplifying the equation, we get our function. 0 is equals to 15.5625 x cubed plus 9 pi x squared minus 5.52. So we have f of x is equals to 15.5625 x cubed plus 9 pi x squared minus 5.52. Now that we get our function, we can now proceed to step 2.
So step 2 in computation, we need to solve for x using numerical solutions. For our group, we use bisection method under roots of equation bracketing method. So a short recap, bracketing method has 4 steps. The first step is we need to select the xi and xu such that a solution exists between them. Step 2, calculate the xr such that xr equals to xi plus xu divided by 2. And then step 3 is to calculate the function of xr. Determine where the true root lies. Step 4 is to select the subinterval that contains the true solution as the new xi and xu. So check the error and repeat step 2 until specified accuracy is obtained. So to start, we know that our function is 15.5625 x cubed plus 9 pi x to the power of 2 minus 5.52. So we get xi and xq. So to get that, we will use the table function on our calculator using fx991es. So click mode 7, that is table, and input the function. So it will ask start put 0 and end put 5. And for step put 1, the result is this. So then we can see that 0 and 1 has changed sign from negative to positive. So we will use it as our initial guess. So we have xi equals to 0 and xq is equals to 1. So in solving x using bisection method, we can use Excel, scientific calculator, or solve it manually. But for our group, we use scientific calculator and we get the following. So as we can see on the table in iteration 11 and 12, it converge. So from the solution using bisection method, we can say that the diameter of x of each in cetopath is equal to 0.400 with a tolerance of 0.20044 and error of 0.00061. So that is our answer to the given question.
So, I am Shiana M. Bigafreya of Group 5, and I will discuss all about using the Newton-Raphson method. So, Newton-Raphson, as we all know, is very easy. It's an open method, so we just make the initial guess for xi. And to solve for the xi plus 1, we will just derive our function. And for our new xi plus 1, we have a formula of xi plus 1 is equals to xi minus f of xi over f prime of xi. In solving, we can use Excel, scientific calculator, or solve it manually. But for our group, we use scientific calculator.
Step 1. Derive the function. When we derive our function, we get f prime of x is equals to 46.6875 x squared plus 18 times pi times x.
Yes. So, let's say our initial guess is 1. Step 3. Input it in the calculator. So, as we have seen in this table, we get the following values of I, x, f of x, f prime of x, and error. So, how can we know the answer? So, we can know the answer if the value is being repeated.
From the solution, using Newton-Raphson method, we get our answer at 0.400 at iteration 6 with an error of 0.00006.
Conclusion. In conclusion, using bracketing in open method, we can say that the diameter of x of each in situ piles is equal to 0.00. As we notice, comparing the two processes in using bisection, we need to iterate in up to 12. So it's a long calculation compared to Newton-Raphson. We just iterate it up to 6. By this, we can say that The open method is the very easy and quick process to solve the situation. Moreover, numerical solution can be applied to engineering problems and provide a way to solve problem quickly and easily compared to analytical solution used in civil engineering. It can be programmed and can be used for any mathematical problem in engineering. That's all for our performance task, and I hope you learned something new. Thank you for watching.